morning, students. Welcome back. I believe you are having a real fun with the magnets and you are enjoying the videos, right? Now, last time we have seen how magnet can be useful to find out the iron content of the soil, how it can be utilized to find out the directions. So where one of the story of the emperor in the Emperor of China, Huang Tai, who was having a statue whose extended arm was always pointing in the south, and how travelers were using the natural magnets to knowing the directions. And so we came to know that magnets, when they are suspended freely, they always point out in north-south direction. And so we can use this property to find out whether the given two pieces are magnets or not. Which one is iron and which one is a magnet. Because when I suspend them freely, only magnet will point out in north-south direction, while the iron piece may not. Okay, and hence from that I will come to know that one is a magnet, the other is not. There is another way, okay, to find out whether it is a magnet or not. We will find out that at the end of this video. Okay, I will tell you. Now, let's now move to the next part, that is making your own magnet. Can we prepare our own magnet? Yes, we can. How? Yes, I am going to demonstrate. What do? Take an iron piece like this, okay, and keep it on a flat surface, okay. So let us see that, how to make it. No doubt, dear friends, there are various methods of making the magnet, but this is the easiest one, okay. So keep that iron piece here, take a bar magnet. Now I am having this bar magnet, okay, and with one pole, keep that one pole at one end of this iron piece like this and start moving. Rub that magnet over that iron piece like this, okay, and lift the magnet with the same pole of the magnet. Place it on the end of the iron piece. Again move it over it, okay. Come to the next end. Lift the magnet. Again bring it to the first end. Move it like this. Okay, you should not change the pole of the magnet. In this way, if you do it for 30 to 40 times, you will find that this iron piece will become a magnet. Check it with the help of iron fillings, okay, and see whether it becomes a magnet. If not, again do it for nearly 30, 40, 50 times and then again check it. Okay, now if I am able to make a magnet like this, can I make a magnetic compass? Yes, you can make it. Okay, so that is activity, next activity. So you can try that, activity number 6. What do? Take a rubber cork, okay, and take a small pin. Now as I have shown the method here, with the same method, magnetize that pin. Prepare magnet of that pin, okay, and insert that pin in the rubber cork. Take a bowl or a glass, take some water in it and put that rubber cork in that. Mind well that the pin does not touch the water. Rotate it, don't move it, don't shake it. Rotate the cork and see what happens. If that pin has become a magnet, once that cork stops rotating, you will find that the needle will point out in north-south direction, and this is your magnetic compass, okay. So try that at home, okay. You can get such types of bar magnets in the market, okay. Swastik or Gajanan bookstores, they have got such types of bar magnets. They can provide you, and take the pin and prepare the magnet in this way, okay, in this method, and insert that pin in the rubber cord and try to prepare your own compass and see whether it points in the north-south direction. Okay, the only precaution that the pin should not touch the water. Okay, now next point we are going to discuss is attraction and repulsion between magnets. Now dear students, they have said one that is a gameplay. You may be having the car toys at your home. So take two cars and place the magnets over them. On car A, place the magnet with the south pole on the front side of the car, and on the car B, place the magnet with the north pole on the front side, and then bring the two cars in front of each other, whose front faces are in front of each other. See what happens. Then change the direction of one car, rear end of one car and the front end of the another car, bring them in front of each other. See what happens. Then what you do? Then bring the rear ends of both the cars towards each other. Then change it again, where rear end of the first car and the front face of the second car. Then front face of the first car and rear end of the second car. Try to do that. See what happens. Now instead of doing that, I am going to show it in a different way. Let us see that. Okay. Now see dear students, this is north pole. These are two cylindrical magnets. This is north pole and this is also north pole of the magnet. Okay. So if I bring them together, let us see what happens. क्या हो गया? Yes, this magnet moves away. Now so that means what? Like poles, they don't come together. They repel. See, you can see. Okay. Now if I change the end of this, now this is south pole. Okay. So if I bring it towards the north pole, it gets attracted. You can see. Okay. Now if I change the pole of this, again you can see south poles. This is south pole, this is south pole. So they repel each other. Okay. Now if I change the end of this, they attract. Okay. Now one thing in the last video I have not told you, that suppose if this magnet is suspended freely, it points out in the north-south direction. So the end of the magnet which points towards north direction, it is called as the north-seeking pole or north pole. And the end of the magnet which points towards the south, okay, it is called as the south-seeking pole or the south pole of the magnet. Okay. So like poles, they repel each other. They do not come together. You can see here. And unlike poles, they attract each other. You can see. So these are the properties of magnets. Okay. So using this property, as I have said, by suspending, I am not exactly 100% sure that iron piece may not point out in north-south direction, because in some cases it may happen that it can point out in the north-south direction. Okay. So what can we do? We can bring the poles together. Now it is always attracting. So definitely one of them is magnet and one of them is not a magnet. So we come to know that one piece is a magnet and the other is an iron piece. So we got the confirmation. And then what we will do? Then we can suspend. So first suspend one of the magnet and then suspend the other magnet, piece which is given. Okay. And the one which points out in the north-south direction, it will be a magnet, and the other will be which does not point out in the north-south direction. Try it for many times. Okay. Because again there is approximation in this rotation. In some cases it may, that this iron piece may rest in north-south. So don't depend on one observation. Take as many observations as you can, and from that go to the confirmation that it is an iron piece or a magnet. Okay. Now the last part. Before that, Booja has a question for you. what will happen if a magnet is brought near the magnetic compass? Okay, so suppose I have got a magnetic compass here. I will show you. So this is the magnetic compass, and if I bring the magnet near it, you can see what happens. Deflection. You can see that magnetic compass needle, it moves. You can see as I move my magnet. Okay, now see here, this is a north pole. Now I am bringing the north pole towards north pole. Okay, so if I move it like this, you can see here. Okay, so deflection is seen. And what will happen, you know, if I bring the north pole of this cylinder closer to here, you will find that the south pole of the compass will come closer and north pole will move away. Okay, similarly, if I bring the south pole of this here, so then the north pole of this will get attracted towards that, because like poles repel each other, unlike poles attract each other. Okay, now some precautions or some cautions to be taken while using the magnet. Okay, see here, you should not drop the magnet from a height. If it falls down from a height, it can lose its magnetism. It should not be hammered. Okay, don't take the magnet and hammer it or hit it on some hard materials. Again, it can lose its magnetism. And it should not be heated. Why? Again, it will lose its magnetism. So these are certain cautions to be taken. Moreover, while you are keeping your magnets, there are keepers. When I am keeping the magnet, see here, they are preserved in this way. The opposite poles of the magnet, they are kept together. Okay, unlike poles. Okay, so this is north pole, south pole, south pole, north pole, and in between they are separated by a wooden piece. This is a wooden piece. Okay, and at the end of the two magnets, there are at the end of the two magnets we have placed here soft iron piece. Okay, you can see at both the ends. Okay, and thus we can protect, because if they are not preserved properly, these magnets, they lose their magnetism. Okay, so these are called as keepers to keep the magnets, and thus we can protect the magnets from losing their magnetism. Okay, then for horseshoe what we do, we place the soft iron piece over both the poles like this. Okay, this is the north pole, this is south pole. So in this way it is kept, and thus we can protect the horseshoe magnet also. So various magnets, there are keepers that are used, okay, to protect them. So you should also take care that these magnets, they do not lose their magnetism. So proper care has to be taken while keeping the magnets, okay, or while storing the magnets, and they should be stored in a proper place, and proper keepers should be used. Okay, then keep your magnets always away from your CDs, that is compact discs, then your mobiles, televisions, okay, and the computer, okay, because it can have adverse effect on these all equipments. It has got its own field. I have shown how strong it is. If the magnet is strong, definitely it will have the effect on these all electronic devices. So always keep these magnets away from your electronic devices like mobiles, computers, compact discs, that is CDs, okay, and etc. So dear students, in this particular topic, we have seen what are magnets, how they were discovered, then what are magnetic and non-magnetic materials, then how to find the ion filing contents, ion particles in the soil. Then we have seen that finding the directions, that what happens if the magnet is suspended freely. It always points in north-south direction. The end it points towards, end of the magnet which points towards the north, it is called as north seeking pole or north pole, and the end of the magnet which points towards south, It is called as south seeking pole or south pole. And we have also seen magnets are stronger at the poles, right? Then we have seen that we can prepare magnets at home by simple methods. No doubt they are temporary magnets, but we can prepare them. And then we have seen that magnets have got certain properties. One is when it is suspended freely, it points out in the north-south direction. Second property, unlike poles, they attract each other. And third property, like poles, they repel each other. Okay? Then certain cautions while preserving the magnets. In case of bar magnets, the opposite poles should be kept together, unlike poles, and they should be separated by a wooden piece, and there should be iron pieces, small iron pieces above and below both the bar magnets. These are called keepers. In horseshoe magnet, iron piece is kept at the poles of the magnets, and thus we can protect the magnets or preserve the magnets. And you should never fall down the magnet, you should never hit the magnet, or it should not be hammered, or it should not be dropped from certain heights, okay, because it can lose the magnetism. So these are certain precautions to be taken while the use of magnets. So dear student, I hope that whatever I have taken you have understood, and you have enjoyed the videos, and you have lot of fun with the magnets. Do the same at your home, because curiosity is most important. If you are not curious, then you cannot have interest in science, and science, you should have that curiosity. So try to make your own magnet, try to prepare your own magnetic compass, and see whether they point out in the north-south directions. Okay, so with that note, let us stop here and meet in the next period to discuss the textual exercise. And so let us stop here, and so thank you for watching my videos, and read the topics, try to understand the concepts. So let us stop here. Thank you.